Welcome to section 922. We're going to be talking about complex roots. Now, complex numbers are in that form of a plus bi. And don't forget, I is the square root of -1. And what's also important to remember is that I squared equals -1. Keep that in mind as we're working through with our imaginary numbers, our complex numbers. Now, we're going to be talking about complex roots. Now, roots are also known as the zeros, the x-intercepts, the solutions. So what we're going to do is we're going to solve number 1. 0 equals x plus 5 squared plus 9. So to solve it, we're going to subtract 9 from both sides. -9 equals the quantity of x plus 5 squared, and then take the square root of both sides. So for the square root of -9, it's the square root of -1 and the square root of 9. So we get plus or minus 3i equals x plus 5. And then you subtract 5 from both sides. So x equals -5 plus or minus 3i. Well, those are our complex roots. Those are our solutions. Number 2. Now, number 2 we could solve using the quadratic formula, or since we haven't done it a little bit, let's use a completing the square. So once again, put 0 in for y. So 0 equals x squared minus 4x plus 9. Then we're going to subtract 9 from both sides. -9, leave some space, equals x squared minus 4x. We're leaving that space because we're going to be adding the middle term, -4 divided by 2 squared, to both sides. So it's -9 plus 4 equals x squared minus 4x plus 4. So we get -5 equals, and we can factor the right-hand side. We get x minus 2 squared. Take the square root of both sides. You get plus or minus I square root of 5 equals x minus 2. Now remember, the square root of -5 is the square root of -1, and the square root of 5. That's where it's I root 5. That's where it comes from. And then just finish up by adding 2 to both sides. So x equals 2 plus or minus I root 5. And there we go. We just found our complex roots. Now, we've talked about conjugates before. And conjugates are in that form of a plus b, a minus b. Complex conjugates are just in that form of, and that's towards the top, a plus bi, a minus bi. So to get our complex conjugate, all we're doing is just changing the sign in between. So the complex conjugate would be 3 minus 2i. The complex conjugate of -4 minus 3i is -4 plus 3i. The complex conjugate of 2i, what really is there is 0 plus 2i. So the conjugate would be 0 minus 2i. So the complex conjugate is just a -2i. And 4 minus I root 2, 4 plus I root 2. We'll be using complex conjugates later on in this section. Now, to simplify, all we're going to do is get rid of the grouping symbols, combine like terms. So we're adding, subtracting. So it's 8 minus I plus 5 plus 4i. Combine your like terms. 8 plus 5 is 13. -I plus 4i is plus 3i. 13 plus 3i is what we get. For number 8, 7 minus 6i. Now for this one, be careful, distribute the negative. -3 plus 6i. When we combine, these 6 i's cancel. We're left with 7 minus 3, which is 4. Number 9, 10, distribute the negative. -6 minus 7i plus 4i. So then we combine. 10 minus 6 is 4. -7i plus 4i is -3i. Number 10, we're going to distribute the 4i. 4i times negative 6 is negative 24i. 4i times I is plus 4i squared. Now, we can't leave I squared in our answer at all. What it is negative 24i plus, and I squared is negative 1, so it's 4 times negative 1. So it's negative 24i minus 4. In standard form, that would be negative 4 minus 24i. The imaginary part goes in the end. In number 11, we're going to multiply the two binomials. 9 times negative 4 is negative 36. 9 times 7i is plus 63i. Negative 2i times negative 4 is plus 8i. Negative 2i times 7i is minus 14i squared. So we'll start combining our like terms. And also, we can't leave I squared. So it's negative 36. 63i plus 8i is 71i. And negative 14i squared is negative 14 times negative 1. So it's going to be negative 36 plus 71i plus 14. So when we combine, we get negative 22 plus 71i. Very good. Now, looking at the next three, they have I in the denominator. We can have I in the denominator of our final answer. What we need to do is get rid of it. Just like we would rationalize when we had radicals, to get rid of I in the denominator when there's one term, we can multiply the numerator and denominator by I. By multiplying by I over I, we're really just multiplying by 1. It's not changing the value, it's just going to look different. So our top number is going to be 3i plus 4i squared over 2i squared. Now we got to clean that up. 3i plus 4 times negative 1 over 2 times negative 1. So it's going to be 3i minus 4 over negative 2. So I like to rewrite this. We can do 3i over negative 2 minus 4 over negative 2. Now we want the real part first. Negative 4 divided by negative 2 is positive 2. 3i divided by negative 2 is going to be minus 3i over 2. And that would be our final answer. We want to split them up so we can both get in standard form. So now, for number 13, a little bit different. We have two terms. Now, here's where that conjugate comes into play. We're going to multiply both of those by the complex conjugate, which is 3 plus I, the numerator and denominator. Once again, by multiplying by that, we're just multiplying by 1. So now we multiply the numerators. We get 6 plus 2i plus 3i plus I squared. Denominator, 9 plus 3i minus 3i minus I squared. Now keep in mind that I squared, that's negative 1. This negative I squared is negative 1 times negative 1, which is 1. So we combine, we get 6 plus negative 1 is 5 plus 5i over. Now in the denominator, the 3 i's cancel. We're left with 9, and it's plus 1, which is 10. And now we split them up. 5 over 10 plus 5i over 10. So what we get is 1/2 plus 1/2 I. And that is our simplified answer. And we're going to do the same thing for problem number 14. To get rid of I in the denominator when there's two terms, multiply the numerator and denominator by the complex conjugate. In this case, 6 minus 3i. 6 minus 3i. So we multiply 30 minus 15i plus 12i minus 6i squared. Denominator, 36 minus 18i plus 18i minus 9i squared. Now, that negative 6i squared is negative 6 times negative 1, which is actually a positive 6. The negative 9i squared is negative 9 times negative 1, which is a positive 9. So now when we combine our like terms, we get 30 plus 6, which is 36. Negative 5i plus 12i is negative 3i. And then it's going to be the 18i's cancel. 36 plus 9, which is 45. Now we split them up. 36 over 45 minus 3i over 45. 36 over 45, they're both divisible by 9. It's 4/5. 3 and 45 are both divisible by 3. So it's going to be minus 1/15 I. And that's our simplified answer. We're going to talk about writing polynomials with these given roots or zeros in the next section. Thank you.